Well, welcome back. This is the second video on reproductive systems of the male and female. We talked a little bit on the last video about the importance of haploid, and haploid meaning half of the chromosomes in the sperm, half the chromosomes in the egg. We have a zygote, a fertilized cell being a zygote, and containing the full 23 pairs of chromosomes. Now, there's a few more things. We're only going to have a couple of videos on this key deal. I kind of targeted in some of the things that we really needed to know, some of the highlights. But remember that the whole chapter, and I say this all the time. So you wonder, why do we do all the questions in the chapter? Why do we do all these other activities? It's because we want to make sure we have everything covered. And okay, so all right, within the female ovary. Okay, once again, what are we talking about here? The ovary produces the eggs. The ovary also produces the female steroids. Okay, so we have something called primordial follicles. Okay, and whenever we hear the word follicle, it's an egg development. Okay, we have the fallopian tubes. Okay, in the ovary we produce this egg, and we have this uterine wall that decides if we have a fertilized. If we have a zygote, or if it's not fertilized, then we're going to release that uterine wall. Okay, we talked about that a little bit earlier. But these primordial follicles, when do they begin their development? Okay, when do they begin their development? And it's really interesting. Okay, it's really interesting because they develop during prenatal development. Okay, so it's kind of interesting. So once again, let's do the question. I kind of started with this one. I kind of saved this for the second video. We'll come and talk about this a little bit more. We're going to get into the book here a little bit. But within the female ovary, primordial follicles begin their development during prenatal development. So what does this mean? Okay, so what does this mean? I'm going to come back and talk about this development. We've got a lot of things about. We got a lot of interesting science on when our bodies begin to develop into the male and the female, and we're having lots of discussion on that nowadays, and a lot of different things. And I want to come back on just a little bit and talk about that, but I want to make sure before I get off on that the different tangents. Once again, within the female ovary, okay, primordial, PRIMORDIAL follicles begin their development during prenatal development. Now, what is the purpose of polar bodies during oogenesis? Now, once again, genesis means the development of. Okay, all right. Genesis means, like in the Bible, Genesis means in the beginning. Well, in this, oogenesis means in the beginning stages, okay, of the development of the egg. Spermogenesis means in the beginning stages of the development of the sperm. So, all right, so what is the purpose of polar bodies during oogenesis? Well, what are polar bodies? Okay, once again, if you've had chemistry, we talk a lot about polar bodies. Polar means they have a positive charge and a minus charge. Okay, so what we have is when we talk about polar bodies, we talk about something that repels each other. Like charges attract, unlike charges separate. So listen to this, okay? What is the purpose of polar bodies during oogenesis? Polar bodies serve both as a dumping ground for extra sets of chromosomes and ensure that the ovulum, okay, O-V-U-M, ovulum, okay, will have most of the cytoplasm. What is the ovulum? That's the development of this new egg. We'll have most of the cytoplasm. And what will we do? The polar bodies serve as a dumping ground for what? Extra sets of chromosomes. So when we say dumping ground, okay, this polar body, okay, we're going to jump chemistry just for a second. It's going to have a positive charge and a negative charge. So there's this incredible, I'm going to say magnetic field, but it's not exactly. It's just a positive charge by chemistry standards. Plus charge is going to combine with negative charges. Is going to repel other like charges, which is positive, and then the negative side is going to repel negative charges and attract positive charges. So extra sets of what? Chromosomes. That's critical. Well, we know right away that an extra set of chromosomes is a problem. We see that in Down syndrome. Okay, but extra chromosomes that are developed in this chromatin material, once again, what's it going to do? It's the purpose of polar bodies during oogenesis. They're going to serve as a dumping ground for these extra sets of chromosomes, and it's going to ensure that the ovulum, O-V-U-M, okay, must have most of the cytoplasm, the liquid part of the cell. So here we go. So here's the egg developing, and as that egg begins to divide, we've got to make sure that we have the right number of chromosomes. Okay, that's the critical part of this whole chapter. Okay, we got to have the right number of chromosomes, and we got to get rid of extra chromosomes. Polar bodies, get rid of the extra chromosomes. Now, during ovulation, okay, a secondary oocyte is released from the ovary. Okay, so what we have is, okay, so when we talk about an egg being released from the ovary, what are we talking about? We're talking about a secondary oocyte. Okay, so the ovary began to develop this type of of mass here that's going to become an egg. So once again, it says during ovulation. So now we're gonna actually make the egg we're making the egg that's going to come through the fallopian tube to be fertilized. Okay, and what is it called? It's called during ovulation the secondary oocyte. Oocyte meaning egg development. Okay, is released from the ovary. Now, which layer of the uterus is shed once monthly during menstruation? Okay, and this is where I was telling you. Okay, so if we develop this egg, okay, and it comes in, and even if it doesn't, and even if you don't have a follicle to release an egg, or the egg doesn't happen, every month the female goes through this menstruation cycle, okay, all right, and so which layer of the uterus is shed? Okay, it's the endometrium, okay. So it's endometrium, the endometrium, okay, what's going to give you the spelling? Endo. Endo meaning what? Inside. Endo meaning inside, and then M-E-T-R-I-U-M, metrium, okay? Metrium means to shed, okay? So the endometrium is the lining in the uterus that once we don't have a fertilized egg, that is shed once monthly during menstruation, okay? Now, ovulation appears to be triggered by a mid-cycle surge in, and the answer is luteinizing hormone. L-U-T-E-I-N-I-Z-I-N-G, luteinizing hormone, okay? So, once again, you have this luteinizing hormone. What does it do? It triggers ovulation, tells the ovary to basically produce an egg, all right? So, ovulation appears to be triggered by a mid-cycle surge in luteinizing hormone. Now, those are some of the main things that we need to know. Let's touch base on some other things. First of all, we have a lot of, the rest of this is just discussion, so just sit back and just kind of take this in some really interesting things. First of all, when couples have trouble, with this process, okay, we check to see, that a follicle is happening, that the egg is being developed. We check to see that the cycle's good. We check to see that the hormones are good. We check to see that the male sperm actually has the ability to go in there and penetrate the egg, to carry the right DNA. It's really amazing, and I know I talk about this often, but it's amazing the way man can control a lot of things, but man can't make new life. So, but what we do is we try to give different things. We try to create the female's ovary. We try to put these hormones in to produce more eggs. Okay, or we try to give the male certain hormones to try to stimulate more sperm development, or to develop stronger sperm. So once again, whenever we hear of all these fertility drugs, it's kind of interesting, because this is where we get interesting things, to where sometimes they will produce a lot. All of a sudden, we might have several offspring in the process, because we produce more eggs than normal, or more sperm, or whatever. But even when we talk about the different ways that we try to do this in vitro, we take an egg out and we mix it with sperm. Once again, humans aren't making human bodies, okay? They're just trying to facilitate this process of two haploid organisms, the sperm and the egg, making a zygote. So I want to talk to you about, when you come in and look at this, I want you to understand meiosis, okay? Mitosis is a division of all cells. Skin cells, lung cells, heart cells. Our body has an incredible amount of cell division going on all the time. It's called mitosis. And meiosis, M-E-I-O-S-I-S, sometimes often pronounced even more correctly as meiosis, okay? You know, in America, we really are sloppy with words, okay? But we're in a functional language where we say things, and if you're in Latin and in Spanish and French, it's a poetic language that goes together. But we're in a functional language. But in meiosis, okay, pronounced correctly, that's the division of sex cells. Now, what's the key? What's the difference between mitosis and meiosis? The difference is meiosis is always haploid. Okay, when meiosis is always complete, meiosis is just division of sex cells. So we were talking about that a little bit. I said we'd come back. That is the division of the cells that make the egg and that make the sperm. So the result of meiosis is always haploid, half the number of chromosomes. The result of mitosis is always is diploid, di meaning two, diploid meaning two sets of chromosomes. Haploid, half the chromosomes, diploid, both sets of chromosomes. Meiosis, haploid, sex cells, the egg and the sperm. Mitosis, all other cells, diploid, both pairs. So, well, we did a really big overview of that chapter. There's a lot for you to look at. We're going to come back and talk about a few other things in this chapter when we talk about pregnancy in the next chapter. So we're going to stop right there. Good luck on your test. And when I see you again, we'll be talking about pregnancy and growth development.